Let's talk about distributed ETL. So once our distributed storage system is set up, in our case, or our use case requires an ETL job, or extract, transform, and load. So as our data source, we will use a database of chemical compounds published by the Department of National Center for Biotechnology Information, um, which which is a an organizational unit of the National Library of Medicine, which in turn is an organizational unit of the NIH, which is the National Institutes of Health of the United States. The database that we're going to be using is called PubChem. This database contains about 110 million chemical compounds. These chemical compounds must be transformed into graph format along with their metadata. So we will store the data. So we will then store our data in our database so that our analytical and transactional systems can use it reliably. So there are several ways to ingest data into our storage system. For practical purposes, we opted to first download the data to a set of edge nodes specifically dedicated for data collection. To carry out the task of transforming and loading the data, we've developed a program in Go and Rust languages that allows us to decode the information and encode it as graphs, together with their metadata. We also use the gRPC client provided by TIKV in order to upload the data to our storage system. Specifically, the Rust component is responsible for decoding the content of the chemical data and encoding it into graph format, which in turn contains the metadata corresponding to the compound. The Go component allows us to make a connection through gRPC with the TIKV server in order to achieve an efficient data load. These components were containerized to enable parallel execution and thus drastically reduce the processing and load time into our distributed storage systems. And let's go ahead and show a demo of how this task or job can be parallelized.